Welcome to homework.
Here the question is, draw the organic products formed in each reaction. So, in the first case, racemic mixture is taken and it is treated with acetic anhydride and then acylase. Actually, it is kinetic resolution where in presence of chiral enzyme acylase, we are getting the specific enantiomer. So, in the first case, A, first of all, racemic mixture when taken and it is treated with acetic anhydride, then the products which are formed should be here. In the first case, what is the product formed? And after that, in the second step, what is the product formed? So, in the first step, we are getting this CH3 CO NH acetylation of amino group is taking place and carbon with one hydrogen here above the plane and below the plane the group given is CH3 twice. This is the group and this is attached to COH group. So this is one S isomer, suppose. This is S isomer, then the same R isomer must be present here. So R isomer should be CH3 CO NH C. Now here above the plane it should be CH3 twice and below the plane hydrogen for the R configuration and here it should be COH group. So this should be R configuration of the same amino acid and acidification or acid with acetic anhydride acetylation is taking place. And when it is treated with, in the second step, it is treated with chiral enzyme acylase, and by that the product which is formed is specific product is formed, that is NH2 and one carbon attached to COH group and here one hydrogen above the plane and below the plane CH3 twice. So this specific hydrolysis is taking place in presence of acylase and we are getting the product that is the S isomer. This S isomer is enantiomer is actually S-valine. So this is the compound formed and the R isomer is not undergoing any kind of this hydrolysis and that is why R compound is regenerated as such and S isomer only we are getting out of this reaction. Now in case of B, what is the product formed. So in B, the compound first formed by hydrogen in presence of chiral RH catalyst. Here RH catalyst is stereospecific catalyst, and in presence of this kind of catalyst we are getting only specifically one enantiomer and not the other one, and hydrolysis of that enantiomer is only taking place. So by this the first compound which is formed by hydrogenation is CH3 CONH 1, 2, 3, and here it is attached to carbon, which is further attached to one hydrogen above the plane, and COH group is below the plane, and here it is further attached to NHCOCH3. So this group is already present, only at the double bond hydrogenation is taking place, and by this hydrogenation we are getting the specific enantiomer, that is the S isomer. S enantiomer we are getting specifically 100%. And after this, when hydrolysis is done, in the next step, the final product will be NH2 1, 2, 3, 4, and here again carbon. Then one hydrogen is above the plane, then COH group should be below the plane, and NH2 group here. So this is the specific enantiomer we are getting, that is actually S-lysine. This is the compound formed in the B reaction. Now what happens in C reaction? In case of C reaction, again hydrogenation in presence of chiral RH catalyst, which is a stereospecific catalyst, is used, and after that hydrolysis. So here also we are expecting the same kind of reaction. And the first compound which is formed is at this point before the hydrolysis, it is starting compound, looking at the structure N, H, and one bond here, double bond, and this is further attached to one carbon which is having NH2 group above the plane, below the plane it is hydrogen, and in the same plane COH group. So this is at this point we are getting this by the hydrogenation. This compound is formed, and by hydrolysis of the same thing we are getting the final product, and the final product is this part need not to take care because this is not taking part in the reaction. here NH will remain same, and here double bond must be there, and this is further attached to one carbon, then another carbon, and at this carbon we should have NH2, NH2, and one hydrogen here, and the COH group. This is the product of hydrolysis, and hydrolysis is actually taking place at this point. That means here this is not NH2, this should be AC group must be present here. So acetylation is already present in the reactant. So here you will write the AC, which is not disturbed actually by the hydrogenation. So, and during the hydrolysis, that means with in alkaline hydrolysis, H2O, this hydrolysis is taking place here, and we are getting the free NH2 group. So by all these steps, we are getting the specific enantiomer, that is the S isomer, and this is S tryptophan. This is the amino acid which is formed by the C reaction. So this is all about resolution, and this is a type of resolution where in the synthesis only we are taking stereospecific catalyst. It can be enzyme or it can be RH catalyst, and by that specific amino acid enantiomer can be formed.